We are going to start with this afternoon session. So we have this afternoon session devoted to art and mathematics, which is an important aspect of math, communication, and popularization, and in museums and in exhibitions. And I have an announcement that the first speaker, Rinke Sundha, has not been able to come here, I believe due to COVID issues. So we only have 2 speakers for this session, which means that we can have some time. We are not constrained so much with the time, but we'll try to keep it in time for the coffee break. So the first speaker of this afternoon is Manya Sundstrom from Curiosum-Umeå University. And she's going to talk us about Nodal for music making.
Thanks. Thank you. Can you hear me okay with the? Thanks a lot to the people who organized this conference. It's a lot of work to organize a conference, and I've met so many people, got so many ideas, and had a lot of fun so far, learned a lot. So thank you very much for that. My name is Manya Sundstrom. I'm American, but I have lived the last 22 years of my life in Sweden, and not just Sweden, northern Sweden, 64th parallel to be correct, just 4 hours shy of the Arctic Circle. And I work at the university, and a few years ago the university decided we're going to have a science center in Umeå. And they have put a lot of money into it, and I was lucky enough to be the person they brought in to work on math. So I'm the math person at the Science Center. I would like to tell you that we are the northernmost science center in the world, but that's not true. There's an orange circle is where I live. Even in Sweden, there's 2 science centers more northern than we are. Probably in Finland.
That is even more.
But I am going to try to make an attempt to be at least the northernmost science center in Sweden that cares about mathematics and takes it seriously. So I've been given random assignments to do, and one of the ones that's been the most fun was to work with a composer. He doesn't know any math, but to work with a composer to do something that connects mathematics and music. And this composer, his name is Jan Färm, and he has worked for many years with a program called Nodal. Nodal is a computer program written by 2 CS professors at Monash University. It's alive, it's being used by people around the world, mostly computer scientists interested in music or musicians interested in computer science. But I think we're the only ones, or at least we're among the first to try to use the program in an educational setting, to use it with kids. What I love about this program is it takes about 5 minutes to be able to write a song, to get into it. So the threshold is very low for being able to use it, but the things you can get out of it are extremely complex, extremely high. So the yield is almost limitless. So I'm going to try to give you a flavor of like both those sides, the easy side and the more complex side. Okay, now I'm going to do a very stupid thing, which is I'm going to try to do a live demo. Okay, so I have to do something like this, and then I'm supposed to take this over to, oh God, is the mouse gonna come? Okay, I may need help. I don't know where the mouse went. Oh, is it there?
It's to the left, so go right. Go right. Right.
yes, okay. This is really weird. I'm watching it there. Yeah, he's the one who said he'll come down and save me. I think I'm okay. But it should be, but I should have a menu at the top. Or? Shall we go to the original screen? Because I need to have the menu. Actually, this mirrors the process of using Nodal in an educational setting. Is 90% is the technical process. Yeah, yeah, it's better. Yes, that's good. Okay, that's good. Yay!
Okay, but maybe.
Yeah, we can fix it.
Okay.
Doesn't have to be the whole screen. It's okay. Okay, so this is Nodal.
Just 10 seconds, so I go to.
Okay. You should have someone like that in your life, like not for just talks, but like everything, you know. All right. Let's see if he's up there.
Okay, go.
Okay, so I'm going to show you how to write a song. So we take away that. I'm going to start with the node button, which lets me put nodes. And if I hold it down and drag it, it will let me make more nodes. Okay, so now I almost have a song. The only thing to know about Nodal is that the length of the lines determines how long the note will be held. And then we're going to be able to control the pitches of the nodes and things like that. That's coming up. But first, I just want to show you a simple song. And here it goes. Okay, now we can do some things like we can change the notes. So this box, the rectangle here, is where everything happens. And this part, what's showing now is the information about that note that I highlighted. So it's a C. 3 means it's the third octave. So if I change that to a 2, it'll go octave down. And the second number is the velocity, so it's kind of how loud it's going to be. And the, what's the third one? I forgot. I never changed the third one. I don't remember right now. And you can also play with changing the value of the note the second time around, so you can have different things happen. So let's see how that one sounds. Okay, less than 5 minutes, we have music. So we can do other things. We can make loops. So for instance, if I take this one and go back here, now you see 2 arrows. It's going to go, and that's an entryway into an enormous amount of fun, because you can, once you get loops, you can do really sophisticated things. I'm gonna do something a little fancy. I think I have to choose a line. Yeah. Should be. So anyway, we try that. Okay, so very quickly, you can add, obviously you can make this as interesting as you like. You can make different shapes very easily, which is, you just click on the line and then you choose this one and yeah, you can change the shape of it. So, I think in order to show you what some of the more advanced things are going to like, I'm going to just actually show you a demonstration that they have. So, I've shown you the easy part. With these simple tools that I showed you so far, you can do even this. Here's one that's a little bit more complicated. You can set it to play in different places. So here's different instruments for every color. So here you go with a more complicated one. And if you are a classical musician, want to have something a little bit more in your repertoire that your parents made you study for, then you can try this one. The dotted lines there, they're called wormholes, and they let you switch from one node to the other, so you can have simultaneous sounds. So that's how they build up some of these complicated ones. And then I want to show you one other thing. This is my favorite one. Fear of bugs. So there's a cool feature. There's many cool features, but one cool feature is that you can show the node counters. Do you see these numbers that showed up? So they're going to register. They're going to register how many times you hit that node. And in the programming, you have an option when you get to make a loop. If you're going to send a line out from a node, you can choose it to fire sequentially, or you can choose it to fire randomly. So this composition was in the random mode, so it's just going to move. Well, you'll see. Can you see the numbers in the back there? Okay, that's for you probability people. Okay, I won't show all of them. I think I'm going to go back to my talk, but let's see. How do I do that? Maybe PowerPoint? Maybe that? Okay. I'm going to show, so I just showed you the basics, and then we looked at these examples to see like what you can do if you really know music and you know the program well. And then the next question is, how do you actually use it as science center? So this is our attempt. We have used it only small scale because my partner got sick and everybody got COVID. So I can't say we've used it with a lot of people yet, but the idea is, so first of all, you can attach a keyboard to the machine. So that means you don't have to type in the notes like I was doing. Second of all, you can use programs like music making programs like Ableton or this. So you can also use your song and sort of do something with it afterwards. It's really easy. It's sort of set up to send music out to a program. And these are the things that we sort of have done and what we have learned by failure. First of all, yeah, we have manuals that in English and Swedish for all of you who want to read Swedish. We have found it takes, even though I think you can get it up and running in 5 minutes, but if you have someone there to help, but if you just have them follow the directions, it takes a little longer, maybe 20 minutes. We have so far used it in workshops. You could possibly use it in just like an exhibit, but you'd have to be a little careful, for instance, so they don't steal the keyboard. And we have some specific tasks. I'm going to show you some of those that we use that like help them focus on some parts of the program. And the main thing we learned is do not give the children the whole list of 176 instruments, because then all they'll do is listen to those. So we have a list that we've just chosen like 6 or 7 instruments that they can play with. So here's some of our tasks. Spooky song. So this one we did for Halloween. I really have a mouse problem. Where is it?
No, it was there. Yeah. It's at the bottom right.
Is it the bottom right?
Yes. Now it's in the middle.
What? It's just invisible. Oh. Yeah, I don't see that on mine.
Get the windows.
Is this a gather?
Yes, it's color.
Below it says cover. Gather.
Yeah. Mirror display.
Yeah, you should be able to see what's
Yeah.
on your screen.
Yeah. Okay, so these are some of the things that we have made as templates for them. Oh, that's the one I wrote this morning. You want to hear? In my hotel room. This is my Paris song. Okay, that's not so good. But anyway, this is another one. So this is from my friend, the composer, and he made this for. This is so simple. All you need to do is make a square, and this is his Halloween music. And I should show you that they have, when you're composing the music, so he has 5 instruments there, and you have a choice. Wait, it's not letting me. Yes, here, use scale. It's not highlighted, but under this box here, you can choose which scale you use. So you can use a major scale, minor scale, Mondrian scale. You know, they have a lot. So he was using one of those. Dorian, I think that was a Dorian scale. Let's see if I should show you one more that we've done. This one, Jan has composed it. And he's used this program with 5-year-olds and up. This is a castle task. So we make the castle, and the first thing they do is to just hear how our castle sounds. And then they can make their own castle on the side. Okay, let's see if there's one more example. Yeah. I think I made this one with the parallel lines. You can use anything to your imagination. You can have a question based on Fibonacci numbers, based on symmetry. You can ask them, to do all sorts of things. But this was with to make music with parallel lines. It's a little better than my Paris song. Okay, and then there was one more I was going to show you with the squares. My friend who's a composer, the one I'm working with, he's more interested in make a song that sounds like a church hymn or he has different kinds of moods that he's after, and then I'm after more geometrical shapes and things. So we kind of combine those two. Okay. No. Okay, so those are the demonstrations. In case I wasn't able to use the live one, I made the pictures. And then I'm gonna show you. So for the most part, we've used this program to get kids to compose music, but we also used the program for our own uses in the museum. So we wrote a song, for instance, for Pi Day. So see if you can figure out what this song is. Can you tell? One has a guess? Yes. It's the decimals of pi by the notes. But first, then it loops, so it's not all of them. Okay. Then I just wanted to give you information if you're interested in this, either like on the research side or just want to play with it. You can download Nodal for free. The only thing that is not on the free version is that you can't save what you do, but you can try out anything. Try out all the features if you want. The guy who invented it or who made it is called John McCormack, and he has a podcast where he talks about how to use it. And there's a lot of videos online about how to do that. And there's also online support for people who are very serious about the programming. And I was reading a little bit before I gave this talk, and they are claiming this is AI, but I don't really understand why that would be classified as AI. But anyway, they claim to be doing AI in this, and that's a topic for later in this conference, right? I don't know. Okay, and finally, I just wanted to give you some images of my home in northern Sweden. First, my partner in crime is Jan Färm, who is really the one who taught me about this program. And the rest of the pictures are just what we've done in our science center since we started a couple of years ago, including the king who came to visit. Thank you very much. Are there any questions or comments?
Questions?
Has anybody seen this program before?
So, yes, thank you. It was very nice. But so you can attach also like a loop station or something like that, or only the keyboard?
It says there's a port that says MIDI in, MIDI out.
Okay,
so as long
MIDI
as you have
and
MIDI.
also like with Ableton,
Yeah.
you can use it live,
Yeah.
or you can just export the MIDI files.
I think you can use it live.
Yeah. And how long does the kids and the visitor interact? Did it happen to you to have people stay there and wanted to finish the song, and you have to let them out?
Yeah. The ones who come to the workshops, they can be there for an hour or so, at least. But when we tried it just like a standalone thing, it was a disaster because I set everything up so it's perfect, and then I left. So my colleagues tried to implement it, and they told me it was impossible to understand. I don't understand what's impossible to understand. It was pretty just making a square, but if you're not the one doing it, you maybe don't know. So I don't have a good answer to the question of how they use it just as a standalone. But yeah, the ones who use it when they get proper support, they can go hours.
So I'm not a music person, but I think I noticed that you said that the length of the line was the duration of the note, but it looks more like it's a silence, like it's not playing for that duration, it's just pauses for longer.
Oh, that is this. That it's the. Aha, yeah, I see. Maybe that's correct.
So maybe there are different
No,
settings?
but there must be settings to do.
Okay.
To do staccato or to do legato. There must.
Okay.
Yeah.
Okay.
Yeah. Is this? Yes. This is space between notes. Maybe I said that wrong.
Okay. And then my other question was, I also got the impression that the shape really doesn't matter that much because what matters is really the distance between the notes. Mm-hmm. Is that correct, or is there?
Yes.
Okay.
Yes, it's just topological. It's just the connection, how long you are from the next note. Yeah.
Okay. Thank you.
Yeah. But it's fun to use the shapes with kids. You know, you can say make a pumpkin, you know, for Halloween or something. You know, so but yeah.
Thanks a lot for the talk. I really enjoyed, and I also see great potential in physical programming, because here these dots and the paths, you can really do it with floor robots or some other kind of physical equipment, which also help the children to immerse and also practice these basics of turtle kind of programming. Yeah. So there might be an opportunity in that.
Thank you very much for the talk. It's very nice, the program. Have you explored some connections of the sound to mathematical properties like symmetry or stuff like this?
Yeah, I mean, that I haven't done so much myself, but it's definitely lends itself to do that. So, yeah, I mean, it's just, the thing I like about this program is that the possibilities are just you're just only limited by your own imagination. You can talk about sequences, you can talk about divisors, you can certainly talk about symmetry, where you're thinking of something specific with symmetry.
Well, I've been working on some similar kind of stuff, and I am trying to recover some mathematical properties out of the sound. And I don't know, symmetry is one of them, or recursion, or autosimilarity, or there are many properties that could be explored through sound, and that's more or less my question.
Yeah, that's a great comment. Thank you.
Yeah, so I have another question, if I may. Like, did you experiment also with rhythm? Because it seems since you can put the dots around, you can make a loop of a square of length 1, and then you can do the diagonal, and then you have two rhythm with are irrational, and so you can explain like fractions with patterns. Did you try it?
Yeah, but the problem is that just when we finished getting this ready to be done with students, then we got the COVID. So we haven't really had opportunity to do everything. But I think that's a really good example of something you could do. Yeah, it might make fractions more accessible for kids who don't understand them in a different way.
May I ask a question?
Yeah.
Do you have feedback from musicians, like teachers in the conservatory, or saying, "Oh, is any professional musician trying to use this for teaching?" Or
for teaching, I haven't heard of anyone who's used it for teaching, but I do make my music teacher friends try the program, and I mean, I know the most common use that I know of is that they're using professional musicians use it for their own compositions. But I don't know the answer.
But I wonder if you can make music without passing through the process of learning to play piano or instruments.
Yeah, it's really gratifying. It's, like I said, it's low threshold. You can easily make a song without having the theoretical background.
We have a question here.
I have a manual for this that I wrote up for education, and in that manual is a section on different notational systems. So, you know, the ones that we have with the circles and squiggles on them, lines on them. Of course, it's only one of many. So I think in Turkish music, there's a representation of notes just by lines, and the length of the line is the length of the duration, and the distance between them indicates the difference of pitch. So this is a little bit more in that direction.
So it was a little hard to see, but there was a mention of a diagonal.
Yeah.
That looked like it was all a grid,
Yeah,
and that you had to choose on a grid.
but you can take away the grid.
So if I can take away the grid, that means that you can pick any length.
Yeah, yes.
So let's say you did a square and then you had something travel along the diagonal.
Yeah.
It would the time duration would be irrational compared to the edge
Yeah.
length. Okay,
Yeah.
that's cool.
That is pretty
So
cool.
you might be. Can you draw a circle? Can you make a circle divided into segments and put the dots on the circle? Things like that.
Unfortunately, you can't make a circle, which is frustrating. There's some really good representations of music. I mean, obviously, circle of fifths and you know, but we can.
Right, but it's just the idea of geometry and
Yeah.
rhythm and trying to get this acoustic connection to those principles of geometry.
Yeah.
Maybe just like compass edge constructions or what have you.
Yeah, that would be great. This is a nodal beta, maybe nodal gamma will. But here you can't do circles.
No problem. Do you have some links to the people doing mathematical music theory? There is quite a bit of
There's
a group. Thomas
Dimitri-
Noll and Guerino
There's a guy named Dimitri Timotsko, for
Okay,
instance.
yeah.
He's in Princeton, and he has a representation.
Timotsko.
He has a representation that's based with a circle.
Yeah.
Then there's, I don't remember the names off the top of my head, but
but okay. That was my question. There's Thomas Noll in Barcelona,
Okay.
who was in Barcelona, and the godfather is Guerino Mazzola.
okay. Well, maybe I can get
Swiss.
some names
Okay.
from you later. Yeah, thanks. Yeah, that's good to know.
Okay, thank you. I think we are going to pass to the next talk. Kristof, thank you for the speaker. So the next speaker is Kristof Fenyvesi. He's from Finnish Institute for Educational Research from University of Jyväskylä. I say that I'm very happy to see him finally because we have been doing projects together. We have finished the project together and we have never seen in person. So.
Exactly.
And it's great to see him here. And he's going to talk us about Mondrian blocks, cognitive training in a box.
Thank you so much, Daniel Ramos, for the nice introduction. And let me introduce also our joint speaker, who is Christopher Brownell.
Chris squared here.
Yes. And actually, as you can see, the affiliation is the same because we captured Chris at least for 2 months. So some kind of brain drain is going on. And he's also representing from this very day, the Finnish Institute for Educational Research.
Yes.
So how do you feel about this, Chris?
Cooler already?
Okay, good answer.
Coming from Central California.
Good answer. So you have some future there.
Yes,
okay.
I
So
mean,
and thanks for the organizers for making possible these physical meetings and saying hellos in 3D after these many years. And why I'm using this saying hello in 3D, because we will go synesthetic now. Okay, so there was music, and we will go to visual music now, because this is the year when we celebrate Pierre Mondrian's 150th anniversary of his birth. And I think this conference, which their Paris and New York is definitely connected, and I see that the German Dada movement is also luring in the background there behind this conference. So it cannot pass without thinking of and talking of and listening this visual music of Pierre Mondrian. Excuse me. Yes. So that's I think it's a great opportunity, and also this is a gift for Sylvie Benzoni. She's in the room. We are also sitting in the same committee. So this is your Mondrian blocks for the Institute for your cafe table. I think it will be used frequently, I hope, at least. And actually, this Nordic, Scandinavian, American session is another good pitch here, because the Manya was also coming from the US, going to the north. And we will move even more towards the Arctics in some sense.
In some sense.
Yes.
We're getting closer.
So, yeah, actually also thanks for this extra time because actually we spent a bit more time to dropping out slides and cutting slides than putting together the presentation. So maybe we'll have some time to
we'll play a little.
To play a little, yes. So in this research group in the Finnish Institute for Educational Research, we are working on innovative learning environments, which not only the physical environment as we know it, but also the community aspects of learning, how the collaborative learning is taking place, how different devices, different toolkits, different puzzles are playing a role in the learning process. So there will be also some references to Professor Silva's talk here, because definitely this is what we so much missed also during the pandemic, this physical connection with the people and these physical aspects of learning and the physical aspects of being in a community when we learn, and this collaborative problem solving, how it contributes to well-being of the students, and also the happiness, the joy of learning. It has also many physical aspects, right?
Yes, it's you know, it hooks you, it brings you in because you can be
exactly.
You can be together.
And when it comes to manipulatives, when it comes to hands-on tools, hands-on games, the connection between the brain and the hand, this is so long ago known, and now it's already highlighted by the cognitive psychology and neuropsychology. So neuropedagogy is also coming into play here. But how it connects to Mondrian. So actually, I'm coming from Finland, but I'm originally Hungarian. And we Hungarians nowadays are more famous about different kind of mind-boggling things. I'm very sorry about those. I have nothing to do with those kind of mind-bogglers. But there is another aspect, for example, Rubik's Cube. So Erne Rubik, if you attended 2010, the Bridges conference, Erne Rubik was one of the main guests. By the way, I'm also contributing to the Bridges conference. I'm organizing the community events. Chris is also involved there. So you all playful puzzlers and good meaning mind-bogglers come there and bring your discoveries to the conference.
When is that conference usually?
Yeah, this year it was in August in Helsinki, so many of you been there, fortunately, so we could meet many of you. And next year it's going to be in Canada, in Halifax, again around end of July, August, I assume, so something like that. You can already check out the details on the Bridges website. And actually, this Mondrian blocks was also introduced at the conference. So you all very familiar with Pierre Mondrian's aesthetic world and his impact to fashion design, and also how it changed our perception when it comes to modern design. And you can see also that's a different thing there. It's not from Mondrian, that's the puzzle inserted there in the row. So this visual connection is played out actually in the puzzle, but there is no generic or organic connection between Mondrian's art and this puzzle, so they have nothing to do with each other, but it's more to help us to also to involve the aesthetics and this visual layer into the play. And actually this event supposed to open the Mondrian year in the New York Museum of Mathematics. Unfortunately, this was also switched into a hybrid event, so it wasn't a fully and online event. But let's hope that at least in the Mondrian +1 anniversary, we can make the live event as well. And of course, there were some hybrid events related to this puzzle also, the International Day of Maths with the help of Imaginary. So what we can say about this playful meditative character of the visual world of Mondrian and the puzzle, you can see some parallels on this slide. And actually the inventor of the puzzle itself was László Mérő, who is a professor of psychology and also a mathematician. And actually he came up with the puzzle as an escape room challenge. And he started to put these squares and started to play around with this little system, if we can call it, on the left hand. And when he recognized that it adds up to 64, and then he started to play around and found more and more puzzles in the set itself. And then he thought that it might be also a good game to continue to develop it further. And then, of course, to make it a real game, a real toy, a retail product from it. It's also an interesting story that how the product design also contributed to the history of Mondrian blocks, and now this is an award-winning puzzle which is available also commercially. And you can see the challenge cards on the right and the game itself on the left. And it also comes in different designs. But let's see how you play the game. So, Chris, you want to comment on?
Certainly. So the game comes with 44 challenges.
88. Yeah.
88. 44 cards with a challenge on both sides of each card. So 88 that are designed by placing. You're given the locations of 3 black blocks. One 1x1 square, a 2x1 rectangle, and a 3x1 rectangle, and they are fixed on a grid. And then your task is to locate the rest of the blocks in the grid.
Yes. So this is the one-player game, and these are the black ones, which are fixed position, and you have to find out the rest, how it comes together. And there are 88 different...
88 puzzles, and each of the puzzles, they range in difficulty as well. There's some research going on about how do you determine whether a particular puzzle is more difficult than another, and we're working towards some solutions on that.
Let's see the the 2 players mode. Just a moment. Sorry, not yet. Here. Yes. So, of course, playing alone, you can learn a lot of things, but playing together, you can... Oh. My friend from... Yeah, okay. Yes, exactly. Maybe he's following the streaming and we made a mistake, maybe. So, 2-player game is more or less based on a NIM type of game. So, you just introduce the NIM games.
So, the goal here is alternating between players. You place a block on the grid and you try to force your opponent not to be able to place you take turns, and then the empty blocks are the empty grid squares are counted up, and those are your points for that game.
Yes.
Yes. Yes. It's very
And
much like
it's very interesting that as Professor Meyer started to discover these games in the set, and then this two-player game actually has been found even after the set has been released. So we weren't aware. that's of course, I mean, it's not that big surprise because creativity is about using the same thing to different type of things. But still, it's very interesting for us that how these new games are unfolding from the set, and how these are contributing to the next versions of the game. And of course, you can also play
Before we go to the tangram, you can play the one-player game, the solo game, as a cooperative game as well with two players. It's quite enjoyable to. We were talking earlier about the connection in community, the collaborative piece of trying to put together, I know the red one goes here. No, that yellow one should go there. And working together, it's a very enjoyable and pleasurable experience too.
Yes. Again, but you have seen also the tangram version in the end. It's quite classic, and so it depends also on the age. So we wanted to have this game very accessible. So this is definitely a good game already for a 3 years old if you want. So at least my daughter liked to play it. And of course there is another level of playing these games, and Professor Silva already opened up the world of these puzzle challenges and how massive events can be, and also how structured learning can also connect. And if we think about the Go championships and chess, of course, it has a big literature even. But actually in China, I don't know how many of you know it, but one of the biggest puzzle competition is taking place there. 50,000 children are involved every year in this huge puzzle competition, and there's a full curriculum by the Chinese Academy where they reviewed all the traditional Chinese puzzles. They have many. You know, Professor Silva, I'm sure you know much more than many of us about the Chinese puzzles. And they reviewed this, and also the modern puzzles, the very up-to-date puzzles from the aspect of learning problem solving. So the Chinese education is very special, especially compared for the Finnish one. So they are really looking for the so-called talented, the gifted ones, and they really want to provide these extra curricular activities to train the higher level cognitive abilities. And actually this is where these future AI programmers are really trained, and this is the competition, which is also a huge media event. You can see how many cameras are moving around, and then you can also see that they selected Mondrian blocks also in the last year, and the Chinese team had a match against a European Union team. So of course European Union team was playing for fun, and just lost against the very well-trained army of puzzle players who were very serious about this. But this is how we play it in Finland. You can see very relaxed, but still on the faces you can see even very similar expressions of deep thinking. So I don't know how to handle this technology. I'm sorry about this. But anyway, I think you got the impression. And this is where we also got to the point that we need to explore this game, but also other games. So we don't say that Mondrian is unique with these cognitive aspects, cognitive characters. It would be very silly to say that this research is about this. But I think these could be and should be explored a bit more consciously with all those games what we are playing. And the main challenge is not to take away the fun of playing, not to take away the joy of playing, but still how to connect it with developing cognitive skills. Yes. But there is still one aspect which is special about this one. That, from cognitive psychology, they use a lot of visual tests to test your cognitive abilities and also to build these cognitive development programs. And one very basic test is connected to mental rotation. So this is what psychologists using it many decades ago. And actually, this game itself is confirmed and also, how can I say, not confirmed, but compatible or can be used also as a research tool for this aspect.
Right, because inherent in this is one simple rotation for the rectangular pieces, right? And so
Yes.
you narrow down the options, but each piece has that switch, except for the
and
three
mental
square.
rotation have the 2D and 3D version. You can see both there. But when you play this game, it's not anymore a psychological experiment situation. So maybe when you are supposed to do the test, you might not motivate it to perform on your best. Of course, that's can also be the part of the test, and scientists are taking care of these kind of circumstances. But here, when you are motivated probably to play the game, and when you have the tool to analyze what you are doing or what the students are doing or what adults are doing, then that leads a bit more information about what's going on, because the test situation itself is not blocking you, but you are motivated by the game. You are in the flow of playing the game. And this led us also to come up with more games which can be also used in this testing and also this cognitive development direction. There is a random selection of, we come up with a lot of them. So how you can limit the play area, how you can make it smaller, starting with smaller kits with similar elements and like different games. This is the block amoeba. You must bring this block to the corner marked with red dot on the right by keeping the connection between the blocks. So you can go step by step like an amoeba to the other corner. And also how you look at the challenge card and then you turn over the challenge card and try to make the same situation on the board. And also that you rotate the board and making the mental rotation actually in your brain and represent that. So this or how to play two games with crossed hands or blindfolded. So and also there were students with visual impairments in Professor Silva's demonstration. Actually, the physical characteristics of the game also allows this kind of playing, or how to play the game for rhythm, for music, for example, to put so these are different cognitive situations actually what can be also tested and also can be used in assessment and also in measurement as well. And when it comes also the digital connection, so we have this game also in a digital version. So even if you are not the head of the Poincaré Institute, but just other participants, you can ask maybe Sylvie to let you to scan this QR code and you will get the free access to the online game, so you can play the game online. And then this digital game also allows us to prepare for this kind of data collection very precisely in this cognitive development aspect.
I have a copy of the game on my phone. If anybody would like to see it later, I'll be happy to show you.
Yeah. So thanks a lot for your attention. And I hope that you became interested in this game. And actually, we have more than 2,000 challenges at the moment available. But we really would like to outsource this, and if you find new game modes, and if you are interested to make it a part of your puzzle economy, that we need to build a puzzle economy from these good games. So we would like to really looking forward to talk you, and also your experience of using puzzles in education. We don't have that experience, so maybe a future project could be also built on this. So this is really a conversation opening talk and a little contribution to this wonderful conference. So thanks a lot for this opportunity.
Thank you, Kristof and Christopher. Yeah, are there
Yes.
any questions?
Right.
Any questions here? Ricardo?
Thank you. I've already downloaded the app, so
Okay.
very nice.
And how is it?
Give me 5 minutes.
Getting there. Okay.
So I have a curiosity. You mentioned that you are trying to measure the difficulty of the cards
Yes.
before.
Yes.
I was wondering 2 questions. One, how you do it, and 2, if you do it also for other games. For instance, I have in mind La Boja, if you know the games, which has also cards, which random difficult. I was curious about that. Thank you.
We're working on that measurement, actually, but the inventor or the designer, Imre, has,
Yeah.
and Laszlo have gone through, and each of the ones that if the 88 that you get in your set, they've determined that this arrangement is very difficult. And usually it comes down to simpler ones make it obvious where the 1x rectangles go. And so that tends to be one measure of how we decide an easy one. How you get to the gradations is a little bit more challenging.
Yes, actually, it's a very, very, very good question, because programming and some sort of AI has been used to come up with all the variations, but then this is the art of puzzle making, the selecting from these huge, more than 200,000 variations, those 88, which is fun to play. And that was actually Laszlo Méry's, because he's a game designer, that was his art part also to making the set. But not now, what we are trying to do is also to using machine learning, and also to using this digital app to find the way to categorize these challenges. And this is what we are doing at the moment, one of the things. Yes.
Thank you very much. I already also downloaded the app and trying to write to the place in CIRM. So it's a big center in France doing mathematics research, and they have a library.
Okay.
They have a little game section, and I think they were asking about games, and I think this would be nice. So first question is, do you... It's more marketing question. Do you present it as a mathematics game or not? I suppose not, but it's interesting to have your point of view, because there is also the question of proving that there is only one solution for some of the puzzles and things like that mathematicians can use or teachers can use. And another question, it's about sociology of competition and relation to mathematics. Do you present the game as a mathematical game or not? And you mentioned Chinese and European approaches, so to say, even though it's... I see that children play differently at the same games, so there is lots of richness and possibility of collaboration on this.
Yes, very relevant questions too, thank you. So actually there is a very small tag on the box. You will have the, by the way, you can give it to, pass it towards Sylvie, and you can check all of you. So it says it's a STEAM game, so science, technology, engineering, arts, and mathematics. But it's a very small tag, and it's presented as a puzzle It's not nothing to do with maths education when you see it on the shelf in the store. But this is another level, and this is another area where we want to have its own story of the game in the education, but we don't want to mix it. So it's not sold as an educational tool. It's there as a game, and we don't even want to change this presentation. But let's say that we are developing now an educational program which implementing, for example, this game. But as I told, we want to have more games. We want to have a game ecology in this approach. And your other question about competitions, that's again something what actually in Finland, it's education and competitions. This is really an oxymoron. So you cannot merge these ideas. And I think I very much agree with that. And actually this game, when we started to recognize its probably educational potential, it was that we saw that there is a kind of a state of the flow, like Csikszentmihalyi wrote, that's what is the flow. And you start to immerse into this problem-solving activity. And even those children who maybe have challenges to focus their attention and whatever, then they also immersed in the game. And we thought that it can be a good gateway to problem-solving activities as well. But we don't see this connection is very necessary, and we don't want to push it to the players or to the children, and especially not the competition itself. We rather imagine like puzzle clubs where this friendly sharing of games is happening, and whoever wants to make a match, then they do it. But that's not the point of the event, that who's the winner, but that's the participation is the point.
Okay. Well, he gave me my microphone. Thank you. Oh, great game and a nice presentation. So especially this games that you can play competitively and collaboratively, because that gives much more opportunities, I think. So, I know. So that's good. But my question is, so your evaluation, you said you did, you track, you log the gameplay, and then you do learning analytics, but then I guess that will be, you can detect within game progression, right?
Yes, this is again what we want to do. So we have many things ready for launching this, but this is what I meant, that if we can start this project, these elements are ready but not yet connected. But we exactly want to do that.
Okay,
yes.
But it's also important to study the transfer to other situations, so something outside the game, and see if the kids learn
exactly
cognitive abilities.
Yes.
So it's the transferability is
yes.
really important as well. So
yes.
that's good if you include that
yes.
as well. Then.
Yes.
But excellent work. Thanks.
Thank you.
We are very interested in soliciting other advice about what other things we should include in that research.
I was just curious, is there, between those versions, like blue one, red one, white one, so if I go into the shop, is there a recommendation which one should I get first?
Well, there is, but I can't tell you now. Imre Kökényesi, who made the product design, he once told me that I think the white is a bit easier set of problems than the others, but I cannot take warranty for this advice. But there is some difference, but actually that doesn't really matter. But I know that I think the white set is a bit easier.
But it's important to note that each of the tasks, each of the challenges is numbered from 1 to 88.
Yes.
And no matter which version you get, and the
yes.
lower the number, the
yeah.
easier the
yes.
task.
Yes.
So I don't know if you know this. I would guess you do. There's a similar puzzle by Gordon Hamilton on Mathpickle.
Yes.
Have you?
Mondrian maths.
Yeah. Can you you would need more pieces, but is there a way that you could play that puzzle with your set?
No, actually, we are also in touch with Gordon. He's also sort of remote part of our think tank or whatever. But his game is based on different game mechanism. Both are that game was also very good. But if you go into that, I don't have time now to explain because I need to think. But in the cafe break, we can talk about it. That's a different game, actually. Yeah, yes. I know the game, but yeah. I think it can be played with the set if you had more pieces. Oh, in that case, yes. Yes.
Okay, so I think it's time for the coffee break. I think we have half an hour. You can wander around, you can go up any place. And let's thanks the speakers of now.
Thank you. Thank you.